Hi everyone, I am Upasana Mishra and welcome to my education channel The Funda. So in today's class we are going to learn about how we can insert a given number of geometric means between two numbers. Also we are going to learn about the relationship between arithmetic mean and geometric mean, and we will also learn about harmonic mean, not in detail but uh, in just definition we will learn because it is not there in the course. So let's begin. So how can we insert a given number of geometric means between two numbers? Suppose the two numbers are A and B. Okay, so these are the two numbers. Now we have to insert n number of arithmetic means between these two numbers. So what does that mean? So you can recall that in when we were reading about inserting n number of arithmetic means between two numbers, and that we had discussed how we can insert n number of arithmetic means between two numbers. Here we have to insert n number of geometric mean between two numbers. So what does that mean? That if a and b are two numbers, then we are going to insert n numbers such that a and the n numbers and b, all these are in geometric progression, are a GP. Okay, geometric progression. That is the meaning of inserting n number of geometric means between two numbers. Okay, so if we insert n number of geometric means between two numbers, then those numbers plus the first number a and the last number b, all those numbers are are in geometric progression. They should be in geometric progression. That is the meaning of inserting uh, number of geometric means between two numbers. Okay. So how are we going to find those numbers such that all these numbers A and those numbers and B, all those are in GP? So how are we going to find those numbers? So as we know that these n numbers, so I'm now going to discuss the process how we are going to find those numbers. So as we know that this n numbers plus the first number A and the last number B, all these numbers form a GP. Okay. So what is the total number of terms in the GP that these all numbers will form? Okay. So here in the middle there are n numbers. You can see here there are n numbers. The first number is A, last number is B. So total number of numbers in the GP is n plus 1 plus 2, so n plus 2. Okay. So total number of terms is n plus 2 terms in the GP. Okay. Now B is the last term of the GP and A is the first term of the GP. Okay. Means we are inserting n numbers, and now we know that the n numbers A and B form a GP. So obviously in that GP that they will form, A will be the first term, B will be the last term, and the total number of terms will be n plus 2. Okay. So A is the first term, B is the last term. So as we have learnt already that the nth term of the GP is known as nth term of GP is A r to the power n minus 1. Okay. So for nth term of GP, or say if I say the mth term, let's not use the term n because you will be confused. So let's say mth term of the GP. So mth term of the GP is A r to the power m minus 1. This formula we had already learnt, okay, in the last class. So B is the last term. So obviously there are n plus 2 terms. So B is the n plus 2 term of the GP. Okay, last term is n plus 2 term. So B equal to first term A into r to the power n plus 2 minus 1. As you know that mth term of a GP is this. So n plus 2 minus 1. Okay. So B equal to A r to the power n minus 1. So in that GP that these numbers will form, uh, B is equal to A r to the power n minus 1, where r is the common ratio. So by solving this equation, we can find the value of r. So r to the power n minus 1 equal to b by a. So r equal to b by a whole to the power 1 by n minus 1. Okay. So the common ratio of the GP that these numbers, the inserted n geometric means and a and b, the GP that will be formed, they will have the common ratio equal to b by a whole to the power 1 by n minus 1. So we have got the common ratio. So now we can easily find those numbers that will that we are asked to insert given number of geometric means. So what will be those numbers? So as r equal to b by a whole to the power 1 by n plus 1, and a is the first term, b is the last term. So the second term will be ar, obviously because they are in GP, so I will multiply r. Third term will be ar square. Fourth term will be ar cube. Like that, the n plus 1 term will be ar to the power n, and this one is n plus 2 term. B is the n plus 2, that is the last term, and a is the first term. So these are the numbers that we are talking about. That is the inserting n number of geometric means between two numbers a and b. So now we have the value of r. So we can just the first term will be, means first inserted geometric mean will be a into b by a r to the power 1. So it will be 1 by n plus 1. Second term will be, second inserted geometric mean will be a into b by a whole to the power 1 by n, 1 by n plus 1 whole square, a r square we are talking about, no? So like that we can calculate. So you don't need to remember this thing, okay? Don't remember this, because you can just, when I will give the question, you can just think that okay, these numbers are in geometric progression, and you can apply the formulas that we have already learned about geometric progression. Okay, so don't need to you don't need to memorize this whole thing that r equal to b by a whole to the power 1 by n plus 1. You don't need to remember. You can without remembering also you can easily solve the questions. So let's solve the first question. So the first question is, insert 4 geometric means between 5 and 160. Okay. So you have to insert 4 geometric means between the terms, that is first term, that is 5, and 160. Okay. So now you may pause the video and solve this question. Okay. So the answer to this question is, we have already learned how we can insert geometric means between two numbers. So we are now inserting 4 geometric means. So that means that the first term is 5. There are 4 terms here, means any 4 terms, and the last term is 160. And this whole 6 terms are forming a geometric progression. Okay, this we had already learnt just few minutes ago. So here it is a GP, and there are 6 terms in this GP, and 160 is the last term or the 6th term, because there are 6 terms, so obviously the last term is the 6th term, and the first term is 5. That means what will be the common ratio? For finding the common ratio, we will apply the formula of GP that we have learned. So the last term 160 equal to a r to the power n minus 1. So a is first term 5 r. R is the common ratio of this new GP that we are going to form to the power n minus 1. So here n is the total number of terms. So here n is 6 as there are 6 terms. So a r to the power 6 minus 1. So it will be 5 into r to the power 5. So 160 equal to 5 r to the power 5. Now, so r to the power 5 equal to 160 by 5 and that is coming as 32. So r to the power 5 equal to 32. So r equal to 2. So if you calculate 2 to the power 5 that will be 32. So the value of r is 2. Now we have got the common ratio of this new GP. So what will be the geometric means? So the first term is 5. Now we have got that the common ratio is 2. So the second term will be 5 into 2, it is 10. Okay. Third term will be 10 into 2, that is 20. Fourth term will be 20 into 2, that is 40. Fifth term will be 40 into 2, that is 80. And the last term that we already know is 160, and if we can also get 80 into 2, that is 160. So these are these numbers 10, 20, 40, 80. These are the 4 geometric means between 5 and 160. So these are the geometric means between 5 and 160. So it was a simple question. So like this you are going to solve the questions related to inserting a given number of geometric means between two numbers. Okay. So now we will learn about relationship between arithmetic mean and geometric mean. Okay. So to derive the relationship, let us take only two numbers. Okay. Then we can just generalize it for all the numbers. So let us take two numbers a comma b. Okay. These are the two numbers. So what will be the arithmetic mean of these two numbers a and b? Obviously the arithmetic mean will be equal to a plus b by 2. This we had already learnt. That arithmetic mean of two numbers is a plus b by 2. What will be the geometric mean of these two numbers? Geometric mean is ab whole to the power 1 by 2, which can be written as root ab. This also we had learned. So we are going to tell about the relationship between arithmetic mean and geometric mean. What I mean by relationship is that we have to tell that if arithmetic mean is greater than geometric mean, or it is less than geometric mean, or equal to, so that we are going to derive here. So if I denote am by a for simplicity and gm by g. So a minus g equal to a plus b by 2 minus root ab. Okay, I have just written a minus b and I have put the values of a and means put the values for small a and small b. So this implies if I take denominator as 2, so it will be a plus b minus 2 root ab. But just by simplifying this equation, I am writing this a plus b minus 2 root ab by 2. So a minus g equal to a plus b minus 2 root ab whole divided by 2. Now a can be written as root a square. Okay. So a can be written as root a square. B can be written as root b square. And we are just writing simply 2 root ab whole divided by 2. Now look at this thing, this whole thing. It is root a square plus root b square minus 2 root ab. Just recall the formula for x minus y whole square. X minus y whole square equal to x square plus y square minus 2xy. Okay, this is the formula for x minus y whole square. So this thing that we have written here, that root a square plus root b square minus 2 root ab. So this is the formula for root a minus root b square. Okay, so if I write root a minus root b whole square, then it will be obviously root a square plus root b square minus 2 root ab. That is written here. Whole divided by 2 because we are calculating a minus g. Okay. So now we have got capital A minus G equal to root A minus root B whole square divided by 2. So we know that the square of any number is always positive. Okay. So let it be a negative number or a positive number. The square will always be positive. For example, 2 square is 4, minus 2 square is also 4. So similarly, the square of any number is always positive. As this whole term is the square of a number, so it will be positive, obviously. And 2 is a positive number. So this whole term that root a minus root b whole square by 2, this is a positive number. Okay? This is a positive number. So that means that this whole term is greater than or equal to 0. Obviously, if root a minus root b whole square by 2 is a positive number, so obviously root a minus root b whole square by 2 is greater than or equal to 0. Positive means actually it should not be equal to 0, but it can be equal to 0. This whole term can be equal to 0 when root a equal to root b. If root a equal to root b, then this will be means root a minus root a, that will be 0. So this whole term, this term in the right side will be always greater than or equal to 0. Now that means that a minus g is greater than or equal to 0. That means that just by rearranging it, a is greater than equal to g. Now a is our arithmetic mean and g is our geometric mean. So arithmetic mean is greater than equal to geometric mean. Okay, arithmetic mean is always greater than equal to geometric mean. This thing you have to remember. Okay, always remember that for any two numbers, the arithmetic mean will always be greater than the geometric mean of those two numbers. Okay, so now let us solve a small question. So if an and gm of two numbers a and b are 10 and 8 respectively, find the numbers. Okay, so we are given that there are two numbers a and b and their arithmetic mean is 10 and geometric mean is 8. So you have to tell me what are those numbers. So now you may pause the video and solve this question. Okay, so the answer to this question is, so now we are given that the numbers are a and b. So here it is given that arithmetic mean of the numbers a and b is 10. So a plus b by 2 is 10. This is the arithmetic mean, a plus b by 2, that is 10. And geometric mean is 8. So root ab is equal to 8. Now by simplifying this equation we can get a plus b equal to 20. Okay, and by squaring this whole equation we will get that ab equal to 8 square, that is 64. So now we have a plus b equal to 20 and a into b equal to 64. So if we are given the sum of two numbers, that is equal to some number, and the product of those two numbers is given, Then what we have to calculate, to get what these two numbers are, we have to know that what is the difference between those numbers. So we have to calculate a minus b. Without having the value of a minus b, we cannot know what the numbers a and b are. So how we are going to calculate the value of a minus b? That I am going to tell. This is just a procedure you can follow for this kind of questions. So a plus b whole square. This is the formula of a plus b whole square equal to a square plus b square plus 2ab. Formula for a plus b whole square. A minus b whole square equal to a square plus b square minus 2ab. Now if I subtract the first, if I subtract these two equations, then a plus b whole square minus a minus b whole square equal to a square and a square will be cancelled, b square will be cancelled. So it is equal to 2ab minus 2ab, so it will be equal to 4ab. So a plus b whole square equal to a minus b whole square plus 4ab. Okay. So this is the equation that we have got. That for any two numbers, a plus b whole square equal to a minus b whole square plus 4ab. Now we will use this equation. Now we have that a plus b whole square is equal to a minus b whole square plus 4ab. Okay. Now we have already known in this question that a plus b equal to 20 and ab equal to 64. Now we are just going to put these values to get the value of a minus b whole square, and obviously by taking the rule we can get the value of a minus b. So a plus b whole square, so here we will put 20, so 20 square is 400. So 400 equal to a minus b whole square plus 4ab. So ab value is 64. 4ab is 4 into 64 and the value is 256. Okay. Now we will subtract this. So 400 minus 256 equal to a minus b whole square. So this is coming as 144 is equal to a minus b whole square. So a minus b is equal to, by taking the square root of 144, and the square root of 144 is plus minus 12. So this is plus minus 12. Okay. So now we have got value of a minus b, and we have got two values actually. So a minus b equal to 12 or a minus b equal to minus 12. Already we have the value of a plus b, that is equal to 20. Now using these two equations we are going to get the value of a and b. So if we use these two equations, so a minus b equal to 12, a plus b equal to 20. So by adding those two equations we will get a minus b plus a plus b. So minus b and plus b will be cancelled. So 2a equal to 12 plus 20, that is equal to 32. So a will be equal to 32 by 2, that is 16. Okay. And if the value of a is 16, just we will get the value of b by putting here a is equal to 16, so b will be 4. This is one value. If I use this equation, so a plus b equal to 20 and a minus b equal to minus 12. So by adding those two equations, I will get 2a equal to 8. So a will be equal to 4. By putting the value of a 4 here, the value of b will be 16. So the answer is a equal to 16 and b equal to 4, or A equal to 4 and B equal to 16. So this is the answer to the question. Simple. Whenever these kind of questions will be asked, just follow this procedure that I have told you here. So let's move. So now we will learn just the definition of harmonic progression. So three numbers A, B, C are said to be in harmonic progression when the numbers 1 by A, 1 by B, 1 by C are in arithmetic progression. So to if the reciprocal of three numbers or five numbers or anything are in arithmetic progression, then those numbers are in harmonic progression. For example, so 3, 6, 9. Okay, this is a geometric, arithmetic progression, because here if I multiply, if I add 3, then it will be 6. If I add 3, then it will be 9. So these three numbers are in arithmetic progression. So 1 by 3, 1 by 6, 1 by 9. These three numbers are said to be in harmonic progression. Simple, okay? Just a new term we are using, but nothing else. And how you can solve the questions of this kind of harmonic progression, then just remember that the reciprocal are in arithmetic progression. So whenever you are given a question of harmonic progression, just do the reciprocal of the term and solve as you have as we were doing in case of arithmetic progression. Just solve that in that way, just solve it and then again do the reciprocal to get the final, means the initial thing, that ABC. Okay, so like that you can solve the questions of harmonic progression. So I am not discussing it in further details because it is not there in the course. So this was it for this class, and in next class we are going to learn about a few more concepts, and we will solve questions of this whole chapter sequence and series, and then we will complete the chapter. So hope you like it, and please like, share, subscribe to my channel, and also press the bell icon to never miss an update from my channel. So bye.